Given a one-dimensional array of numbers, find the max sum of the contiguous subarray within that array of numbers. So what we'll do to solve this problem is we'll initialize two variables, best sum and current sum. We'll initialize current sum to 0 because when we start iterating, the current sum will, before it's added, be 0. And we'll initialize the best sum to the 0th element of the array. Now, we'll iterate through the array. Through the length of the array. And increment as we go. Now, in this for loop, what we're going to do is assign values to current sum and best sum. The value we'll assign to current sum is the max between the ith element in the array and the current sum added to that element. So between array of I and current sum plus array of I. To best sum, we'll assign the max between the current sum and the best sum. We'll close the for loop and return the best sum. Now, let's test how this works and assign it a time complexity and space complexity. So let's get a sample array of numbers going. Let's say, loosely, array equals 1, -5, 2, and 4. So what's going to happen through this array is best sum will be initialized to 1. Current sum to 0. We'll iterate for when I equals 0. Current sum will be assigned the max between the ith element, so 1, and 0 plus 1. So because those numbers are the same, current sum is assigned to value 1. Best sum is assigned the max between current sum, which is 1, and best sum, which is also 1. So best sum stays as value 1. Now we move on to I equals 1. current sum is the max between the ith element, -5, and the current sum plus the ith element, which is -4. Best sum is assigned the max between best sum and current sum, which is still 1. Moving on to I equals 2. Here's something really interesting is going to happen. So we take the max between the ith element, which is 2, or current sum plus the ith element, so -4 plus 2, which gives us -2. 2 is the greater of both of those, so current sum gets assigned to 2. Essentially what happened is because this ith element for I equals 2 was greater than the ith element plus the current sum, the first two elements of this array were dropped off of the sum. So now we'll check for best sum. Current sum is 2, and the current best sum is 1, so best sum becomes 2. Now, moving on to I equals 3. Current sum is the max between the ith element, 4, and the current sum plus the ith element, which is 2 plus 4, which is 6. The max between those is 6. Current sum is assigned the value 6. So for best sum, we check what's the max between the current sum and the best sum. What's the max between 6 and 2? The max between that is 6. Therefore, since we're done iterating through this array, we'll return 6. Now, on to the time complexity and space complexity. So, for the time complexity, we have a for loop, which by itself is O of n. Inside this for loop, every time we're finding the max twice between two values, that has a constant runtime. So our time complexity is in fact O of n. And for space complexity, we have two variables that we initialize and nothing else. So our space complexity is constant.